exercise 127, question number 5, I'm going to look at part A, multiplying Z1 by Z2, but then as an extension I'm going to look at Z2 divided by Z1. So you could have a go at that after you've gone through this question and try it yourself, see if you can do it. The extension questions 8 and 9 and 10 will also involve division, but you will have to do a division in your questions, so you need to practice them. So going back to this, multiplying these, Z1 times Z2, we just multiply out the brackets, which means initially you treat them like any bracket. You multiply every term in the first bracket by every term in the second, so 1 times 4, 1 times minus 3j, and then 2j times each of the terms. So that's effectively what I'm going to do. And then I need to collect together like terms and remember what we do with j squared, because we're going to get a term in j squared. So see if you can do it. I'll run through the solution below here. So 1 times 4 gives me 4, minus 3j plus 8j minus 6j squared. Now collect together like terms. 4 minus 3j plus 8j is 5j minus 6j squared. But remember that j squared equals minus 1. So effectively that just changes the sign of the minus 6 to make it plus 6, and it becomes a real number, which means I can now add together the 6 and the 4 to get 10 plus 5j, which will be my final solution. Okay, now let's look at the extension question to do this division. Have a go at it. Remember, it's to do with multiplying top and bottom by the complex conjugate of the bottom number, which, as a reminder, is the same as the bottom number, only with the sign changed. So this equals 4 minus 3j times 1 minus 2j over 1 plus 2j times 1 minus 2j. So you can see here that actually this fraction here is exactly the same as this fraction. All I've done is multiply top and bottom by 1 minus 2j. So I could easily cancel them out and I'd be left with the same as I had before. But there's a reason why we do that, and that is because we can, multiplying at bottom, we get 1 times 1 is 1, minus 2j plus 2j minus 4j squared, which equals 1 plus 4, which equals 5. So in fact, because this always works, because by multiplying by the complex conjugate we actually cancel out these complex parts, and then the j squared always gives us a plus number for the 4 that follows. We always end up with effectively the first number in our bracket squared plus the second number in our bracket squared. So it becomes 1 squared plus 2 squared, which is 4. And so we can actually jump straight from here to here to the bottom. So that gives us 5. So the top bit, what do we do for the top bit? Well, we multiply out the brackets. 4 times 1 is 4. 4 times minus 2j is minus 8j. Minus 3j times 1 is minus 3j. Minus 3 times minus 2j is plus 6j squared. So collecting together like terms, that means we get 4 minus 8 minus 3 is minus 11j minus 6, because again j squared is minus 1. So now I can collect together the real numbers, so that's minus 2 minus 11j. So now what we do is we divide each of these numbers by 2. We split the fraction into minus 2 over 5 minus 11 over 5j. And so we can work out what minus 2 over 5 is. That's negative 0.4. And 11 over 5 is minus 0.22, 2.2 rather, j. And that would be the final answer.